caustic soda, NaOS. Now, manufacture of caustic soda. There are two different methods for the manufacture of caustic soda. First method is Castner-Kellner process. This, and second method is Kellner-Solvay process. Let's discuss about first method, Castner-Kellner process. In this Castner-Kellner process, a large rectangular iron vessel is taken. This is large rectangular iron vessel, which is divided into three compartments with two slit partition. This is slit partition, this is slit partition, which divide this rectangular iron vessel into three compartments. Two outer compartments, this is outer compartments and this is outer compartments, and another central compartment. Outer compartments contain saturated brine solution. This is saturated brine solution, this is saturated brine solution, and graphite anode. This is graphite anode and this is graphite anode, while a central compartment initially contains water. This is water. Water is added through this inlet to this central compartment, and it contains iron cathode. Look, outer compartments contains graphite anode, this graphite anode, and central compartments contain iron cathode. Now, a thin layer of mercury can flow from one compartment to another compartment in the bottom of this rectangular vessel. This is thin layer of mercury. This thin layer of mercury can flow from one compartment to another compartment with the help of rocking motion of eccentric wheel. This is eccentric wheel. It creates rocking motion. With the help of rocking motion, this mercury can flow from outer compartments to central compartment and from central compartment to outer compartments. This mercury acts as cathode in the outer compartments. Here it acts as cathode, minus, here minus cathode, while it acts as anode in the central compartments. Okay, when electricity is applied across the electrodes, brine solution in the outer compartment gets ionized into Na plus and Cl minus. The brine solution in the outer compartment, in this outer compartment, this brine solution, that is NaCl, gets ionized into Na plus and Cl minus ion. Cl minus ion migrates to the graphite anode towards this anode. Cl minus ion migrates towards graphite anode, where it lost electron and converted into chlorine gas, Cl2 gas, which escapes out from the outlet. Chlorine gas escapes out from the outlet from this side. From this side, it escapes out from the outlet. Reaction occurs like this. Look, at outer compartment, NaCl gets ionized into Na plus and Cl minus. Cl minus migrates towards the graphite anode, where it lost 2 electrons and converted into chlorine gas, 2 electrons. Cl2 plus 2 electrons, here is 2 electrons, and chlorine gas escapes out from the outlet, while this Na plus migrates towards the mercury cathode, this mercury cathode in the outer compartment, this mercury cathode. Na plus migrates towards this mercury cathode, where it gets discharged by accepting electron into Na. It is converted into Na, sodium metal, which further combines with the mercury to give homogeneous mixture called sodium amalgam. Here, here sodium combines with mercury and forms sodium amalgam. This sodium amalgam moves from outer compartments to a central compartment from either side, from this outer compartment to central compartment, and from this outer compartment to central compartment, with the help of rocking motion of electric eccentric wheel. When sodium amalgam reaches to the central compartment, it combines with water of central compartment to give NaOH, caustic soda, and hydrogen gas, and 2 mercury gets deposited, which is reused at the base of the rectangular vessel. Look here, mercury gets deposited, 2 mercury gets deposited as mercury metal, and sodium always combines with water to give NaOH and S2. Everywhere when sodium reacts with water, it gives NaOH and S2. Thus, now the central compartments now contains aqueous NaOH solution. Now this, after reaction, this completely becomes the aqueous NaOH solution, and this aqueous NaOH solution is taken out from the central compartment and evaporated to get the solid caustic soda. From here, aqueous NaOH taken out and then evaporated up to dryness to get the solid NaOH. In this way, caustic soda is manufactured from Castner-Kellner process. Now let's read through. Castner-Kellner cell consists of a large rectangular iron vessel divided into 3 compartments with slit partition. 2 slit partition divide Castner-Kellner cell into 3 compartments. The 2 outer compartments contain concentrated brine solution, means 2 outer compartments contain concentrated NaCl solution with a graphite anode in each outer compartment, and central compartment contains water with iron cathode. Central compartments contains initially water and iron cathode. Mercury is allowed to move from one compartment to another in the base by means of eccentric wheel. Mercury acts as cathode in the outer compartments and acts as anode in the central compartment. Mercury, which flow in the base, acts as cathode in the outer compartments and acts as anode in the central compartment. When electricity is passed, electrolysis of brine solution occurs in outer compartment. First, electrolysis occurs in the outer compartments. Now reaction occurs like this at outer compartment. NaCl ionized into Na plus and Cl minus. Cl minus migrates toward the graphite anode and converted into Cl2, which escapes out from the outlet, and Na plus migrates towards the mercury cathode and gets discharged into sodium metal, which combines with mercury to form homogeneous mixture sodium amalgam. Thus produced sodium amalgam at outer compartments passes to the central compartment due to rocking motion of eccentric wheel and reacts with water to form sodium hydroxide with liberation of hydrogen gas. This hydrogen gas escapes out from this outlet from the central compartments here. Now reaction occurs like this. NaHg, S2O, 2Hg, and NaOH. Sodium hydroxide is taken out from the central compartment and is evaporated to get the solely NaOH. In this way, caustic soda is manufactured by Castner-Kellner process.